Hi, everybody. I am Forrest Monsen, and next to me is the illustrious Alex Maestretti. Alex directs the security, intelligence, and response team at Netflix, and I'm a senior security engineer on his team. We're going to be talking to you this afternoon about threat hunting on AWS, Amazon Web Services. So we do this at Netflix, and given Netflix's scale and cloud and DevOps maturity, we find the challenges we face to be incredibly interesting, but also, given that scale, that maturity, we find the things we're able to do, the ways we're able to hunt, to be very interesting as well. So that's why we're sharing, because if you're not there yet, we want you to get excited about it too. And we think when you see and hear about some of these things, you will. So we're going to talk about a pretty broad range of tools and tactics that our environment enables, most of which we're using now. We hope you'll be able to take inspiration from what we're currently doing and get some ideas from what you might do in this environment too. Our goal is to make you better threat hunters, and no matter your current level, we're going to do this by presenting 3 scenarios that go progressively higher into the AWS cloud, increasing the scale and speed at which you can perform threat hunting operations. So in the first, there's a series of unfortunate events that occurs, and you're going to hear me talking about familiar Linux live response tools and scripts used on an instance. However, if you're not already taking advantage of the AWS orchestration layers and APIs to supercharge your threat hunting and live response, it's a good time to start looking into it. I'll discuss some of the work that I'm doing with EC2 Systems Manager. In the second scenario, when stranger things start happening, you'll have to up your game and go a little higher into the cloud. You'll hear from Alex about ways to use AWS-specific capabilities to execute strong control over your attackers. And finally, the third scenario is going to be full cloud. So in this scenario, your attackers are completely aware of your AWS setup. They're highly capable and as silent as possible, and you're being specifically targeted. That is, they're directly attacking your AWS capabilities, not just your instances. So you're going to have to go ultimate beastmaster on them. So conventional hunting in the cloud. First scenario, it is conventional hunting and live response, but it is in the cloud. So here you are on a weekday afternoon. You've got some time set aside, and you decide to check common persistence locations on your web front end, since it represents a significant risk to your business if it were compromised. You're going to query the ELB, that's the Elastic Load Balancer, for a list of all of the instances associated with this application. It's because it's horizontally scaled, and the ELB is going to tell you what it's fronting. Remember, we're still building off this conventional model where you have live response tools, such as a script or statically compiled safe binaries. You're already aware of the issues with evidence dynamics, et cetera, and you're interacting with these instances simply to search for signs of compromise. A little aside, if you're not already familiar with SSM, that's the EC2 Simple Systems Manager. It was launched in late 2015, so it's been around for not quite a year and a half. An SSM agent is going to run on any instance you specify and execute scripted commands remotely or take other actions on your behalf. It does a heck of a lot on Windows. You can run updates, install PowerShell modules, run PowerShell scripts, set up CloudWatch, etc. We're going to focus on Linux here, as I said. On Linux, if you use the run command action and the canned AWS run shell script template, for example, it's going to log all the commands run, their standard out, their standard error, and it's going to optionally dump your results into the S3 bucket of your choosing. You could, for example, name these with the instance or the incident number of something you're working. If it can't execute commands, it's going to queue them, and it's going to wait until the agent is ready to execute those. So you don't have to log in via SSH or RDP to administer this machine. It gives you the ability to manage a fleet of instances at scale. So you can probably see this is a great potential tool for hunting and live response. It's a capability that Alex and I are developing at Netflix, and we hope to be able to share more later. I should add that when using EC2 Systems Manager, or SSM for short, you're using the binaries on the system, and that might raise a red flag for you. But you don't actually have to trust those. You can write a straightforward Python script, for example, and use Python to statically compile it and get it on your instance by pulling it from S3 at response time. So in this example, back to a series of unfortunate events, you're running Linux on your web front end, and you pull the list of instances from your ELB, your Elastic Load Balancer. You don't log into any of these instances. You run an SSM command to run your script, which has pulled back persistence locations generated from, say, the Forensic Artifacts repository on GitHub. Shout out here to Greg Castle and Joaquin Metz for that. Your script is going to compare the files you found to your golden master AMI, your Amazon machine image. And that's your reference image. You're familiar with that in a conventional environment, I'm sure. And something sticks out, something that shouldn't be there. It's a startup script. It's in etc/initd/db security spt. As it turns out, that is a match for a file name that the Bill Gates Trojan variant generator will produce and drop on your system, on a compromised system. And it turns out it's on 6 of your web front-end instances. So are you going to have to log in to conduct live response here? No, you're not. You have SSM. So at this point, you snapshot all of your running instances. That's the root EBS volume, the elastic block store of each of those, using the AWS console, or a script that uses the AWS API, right? You're going to work only on your snapshots, of course. You could easily share any of these snapshots with anybody else if you wanted to, maybe have them analyze it. But in this case, you're going to be moving forward on your own. So here you're going to use SSM to execute to pull your statically compiled safe binary from S3. We're going to pull it this way, and then run your commands and send the results back to S3. It's timestamped and logged. That happens in seconds. You're going to collect system information, mounted file systems, users, interfaces, the routing table, open file handles, everything of value, and you're familiar with that. This is live response in action. And now you're going to grab volatile memory. So you've already compiled the Lime kernel module and left it on S3 here. Lime allows you to grab system memory. You may already be familiar with that. So again, you send the SSM agent commands to download and insert the module and acquire system memory, and then drop it back on S3. So I'm not going to be going into it, but a great option here is Margarita Shotgun by Joel Ferrier of the threatresponse.cloud guys. And that is bigly, so you should go check it out. You can stream your memory capture to S3, and they've done great stuff with AWS_IR as well. Next, you're going to add these instances to a lockdown security group, or SG, that only allows access from SSM or S3 and your forensics instance. You're going to have one of those in the cloud. That's scriptable too. So your afternoon's running. That hasn't been that much time, maybe 10, 15 minutes. The memory capture might still be running, but when you take a break, you're going to inform the web team via chat about the suspected compromise, and they're going to respond. In this scenario, they respond and say that they happen to be using some old WordPress plugins, and they didn't keep them updated. I'm not sure if that's ever happened to any of you. But now what you can tell them is, go ahead. I've already set aside snapshots of all of these instances. Go ahead and roll a new cluster, a new autoscaling group, and have a plan to keep these updated in the future, please. So you've got those all set aside for your further examination or another team, perhaps. So here's the thing. In the next scenario, you're going to turn up logging if you haven't already done that. So by rolling that cluster or autoscaling group and turning up logging, you're forcing your adversary to come back in through your gates under greater scrutiny. So bear that in mind. So that was a series of unfortunate events. And by getting familiar with these, though, you're going to be much more prepared when stranger things start occurring. So let's advance here. And I want to turn it over to Alex. He's going to describe the next 2 scenarios.
Thanks, Forrest. Cool. So I think what was really powerful about some of the stuff that Forrest shared is the low upfront overhead of developing that system. Right? We talked about a few times this morning trying to lower the barrier to entry to get more folks in the fight in hunting, and this is a great way to do just that. Right? Rather than having to build a large deployment of endpoint monitoring or a logging pipeline, you can use the things that AWS is giving you for free and go ahead and push out a live response script using SSM, and it does all the queuing, all the scaling. So you you take the skills that you could use to investigate 1 or 2 boxes using SSH, and all of a sudden you're doing it at cloud scale, right? So I think that's very cool. I think the other thing that he sort of led into was the idea that you can be much more aggressive in your hunts in the cloud. And it's partly being in the cloud, and it's partly being on a more modern tech stack. So I just want to divert a little bit here and talk about sort of microservices and modern DevOps practices. So that's what really it makes hunting a lot of fun in our environment, is that if you've decomposed your monolithic applications into microservices, each individual unit is operating on a smaller set of data, and so you get a better signal-to-noise ratio, and you kind of figure out what things are going on. And then on the DevOps side, you've got ideally immutable and ephemeral instances that are being deployed through a CI/CD pipeline, a continuous integration, continuous deployment pipeline. So in that case, if they are immutable, then they're very close to that gold image that Forrest mentioned, right? So again, your signal-to-noise ratio is greatly improved. And if they are ephemeral, it means they don't last very long. So they're meant to come and go, which means you can be very aggressive as a defender in knocking those off. And as you mentioned, rolling entire new clusters to try and see what that does to the adversary. And that's how I want to tie it kind of back to the abstract, what we talked about, our definition of hunting. I think there's a range of security sort of operations that you could consider hunting. And on one end, you have more of a continuous monitoring operation where you're looking for known bad or maybe some anomaly detection that's going on all the time. And then at the other end of the spectrum, you have what I consider true hunting, which is bounded operations that are bounded both in time. So you're only going to do it for, whether I think there was 2 hours this morning and 4 hours, maybe a couple days. If it stretches into weeks, you probably want to decompose that into multiple hunting operations, but also bounded in terms of focus. So we heard this morning about knowing your terrain, right? Knowing what the weather is in your environment. So if you're going to set up a hunting op, you want to really focus in on a microservice or a piece of data you know will be valuable. So you need to know your terrain, you need to know what the adversaries are after, how they move through an environment, and then you can identify those choke points that you want to monitor, the essential data that they're going to come after, and that really sort of ups your hunting game. And that final piece is being able to change the environment, to create those choke points, to create those opportunities. And to be able to do that, it really helps to be in a cloud and a modern stack because you can change things around on the fly through an API. All of your infrastructure is code. You don't have to rack boxes and things like that. So we'll talk a little bit more about that going forward. That works. So yeah, so here we're into Stranger Things. Forrest had talked about using live response scripts, fairly traditional. We're going to talk a bit more now about using logging, which I think is really what we'll all be doing more and more of, right? We'll always have logs, even if we start to lose some visibility on other sections of our infrastructure. And the great thing about being in AWS is there's lots of logging sources that you get, again, for free, for no engineering up front. Right? You might not want to build a logging pipeline to capture all of your Apache logs, but you don't need to if you're in AWS. You can get that from other sources. So here we've got a picture of a sort of a generalized microservices unit, right? You've got some sort of discovery on the front end, in this case DNS. You've got that load balancer we mentioned that's serving traffic across an auto-scaling group of instances. Again, these instances are built from source through a CI/CD pipeline. They're deployed multiple times a day. They don't live more than 24 hours. So they come and go as they please. If they need more scale, they scale up. If they don't need less, they scale down. If you want to terminate one or move it into quarantine, the customer never knows the difference. There's no hit to uptime. None of your DevOps guys come after you. So you can be very free in your response activities. And they basically take some simple information, they reach out to other microservices, they compose a response, and they send that back up the pipe. So that's, again, a microservice sort of subunit. So if we look at this and say we've already identified this microservice as being valuable, it processes something an adversary would want, grandma's secret cookie recipe, CCN, something of value, you can say, okay, I'm going to hunt on this microservice. And then we look at it and we see an obvious choke point at this ELB. And fortunately, with a couple clicks in the console, you can turn logging on that ELB and send those logs right to an S3 bucket. And S3, for those who aren't familiar, is just a block store. So you're basically storing text files in this S3 bucket, very inexpensive, very high performance, good backup characteristics, really a wonderful technology. So you could then take those and ETL them into some sort of data pipeline. But again, if you don't want to spend any money on engineering up front, then you can point this thing called Athena at it. And Athena will go ahead and give you big data capabilities sort of on the fly, on demand. So you pay per megabyte scanned. You have to spend a little bit of time creating an ingest algorithm for it or ingest schema, essentially. But those are available online for all of the common log formats. And then when you want to search it, you write SQL-like queries, kind of like you would for Hive. And it just goes ahead and it'll process this data in a massively parallel fashion. So if you have a large deployment, you get a lot of logs you want to crunch through, Athena will do that very quickly with no upfront overhead. So let's dive a little bit more into that example, right? So we found a persistence location, we rolled the whole scaling group. Our assumption is that they're going to come back in. So we found their persistence location, but we don't really know how they got there. We might theorize they probably came in through the front end. Maybe there's some vulnerability in our web app. We've got these WordPress things that aren't updated very often. So we'll probably want to look or hunt for their attempt to reacquire. And we'll do that with ELB logs. So the ELB log format you see here from the Amazon documentation is very similar to a weblog. You've got a timestamp and you've got a request and some of these other sort of objects here. I don't know if you can really, oh good, you can see up there. So up there you can see I've highlighted some fields that might be viable for hunting. So these also, when you consider hunting, there's sort of two general categories. Either you have an IOC, you've got an indicator of compromise you want to find, or you're just looking for weird. Right? So in this case, we don't really know how they're coming on. We're just looking for weird. But if we did have an IOC, that'd probably be some sort of a substring match on the request. Say they had a PHP backdoor they were hitting, that would be in the request. It would pop right out. It was mentioned this morning, a lot of these guys will roll their own tools and they'll misspell the user agent or they'll miscapitalize it. You'll see that especially if they're doing sort of volumetric attacks, right? They'll pre-compute the headers and they'll mess it up. So you can find those. That's a good IOC. Or you can also use that, like these other ones, to try and do frequency counts, which is sort of another standard hunting procedure. So you could look at any of these fields. Receive bytes might be a good one. Again, if this is a microservice, these fields shouldn't vary all that much, right? If it's a microservice that does weather updates, it gets a zip code, it sends a temperature. It gets a zip code, it sends a temperature. If all of a sudden it gets a megabyte of request, that's worth looking at, right? Maybe they're trying to overflow a buffer. Maybe they're trying to drop an exploit of some sort. Similarly, if it responds with a huge chunk, maybe that's some sort of memory sanitization issue like we've seen recently, right? It's returning more memory than it should. So both of those instances might be things you want to delve in deeper on. Other things, same backend status codes, right? The struts thing that happened recently, if that exploit landed, it gave a response code, so you could find those pretty easily. Backend processing time, if it takes much longer time, it probably went down a different code path to execute. Maybe they're trying to find something hinky on the edges there. So any of those things could lead to follow-on investigation. You're probably not sure that it's something bad yet, but it's something that's worth checking into. So in order to do that, you need to then pivot back to the instance and essentially run SSM again, or however you want to respond to it, right? You can do the quarantine thing or the snapshots. So to do that, you've got the backend here highlighted in green, and that's the IP address of the instance that served that particular request within the auto-scaling group. That is very likely a private IP space. So usually I'll pivot through the describe load balancers one more time, get the list of instances, filter on that IP address, then I know where I'm at, and I can continue my investigation. So quick digressions, I think we have time. Some of the ideas that we have around what that response might look like, and this is kind of where hunting bleeds into IR and bleeds into deception, is you could try and then control your environment, right, if you know the directions that they're coming through. And that might be looking through these log files and detecting the event that you found, and then using a Lambda script to automate your response. So we already use scripts, right, to improve our automation process. With Lambdas, you can basically push these scripts into the cloud and they're hosted there. So you can either trigger them manually during a response, or you could have an event like this trigger and then take some action. So one easy one, again, because we're able to take out these instances at will, is you simply pause that one. So that freezes memory, it takes it off the network, and it makes it sort of, I wouldn't say it's fully forensically sound, but it's in a good state for you to come back, look at it later. You can move it off. It's now safe. It's not going to be able to access any of your information, but you can come back at a later time. Maybe you carve that responsibility off to a team member. Maybe you could use a third party and just ship them that paused instance to play with. Other things you could do, this is an ELB example, but there's also an ALB, an application load balancer. So that one is actually aware of URLs because it's able to load balance across different API endpoints. So in that case, say you had that same PHP example, right, and you wanted to play a little deception game with them. You could say, all right, if I see the URL for the PHP backdoor, I'm going to shunt that to a decoy instance and just sort of see what they do. Maybe I can get some more IOCs out of that I can look elsewhere for. Maybe I can get them to drop secondary tools. But you can control the flow of the adversary with some of these functions. And add an ALB, or you could add a WAF, right? You could add a web application firewall and simply block that at certain places to try and funnel them into your choke point. And the great thing about having this sort of infrastructure as code idea is that you can deploy that in front of your, let me go back one, in front of your load balancer quite easily, right? It's a few clicks on the console or some code in the API, and you've spun up a WAF. You don't have to go rack a box and program it and do regression testing and all these things. You probably have multiple clusters running. You throw up a WAF, you do some red-black testing, and you're off and running. You're able to be much more flexible in your control of where you're sending your adversary. So that's an example of using sort of logging from AWS about more traditional vectors, in this case, web servers. The next one I'd like to talk about is cloud-native threats and cloud-native hunting. So in this case, we've got these great Amazon APIs I've just described, right? They're great tools for defenders, but they're also great tools for attackers. So you have this whole new attack surface on the AWS API that's not super well understood, but it's a lot of fun to try and figure out how to abuse. So if you are an attacker and you are aware of AWS, you might use it to facilitate any sort of spot on your attack kill chain. In this case, we'll focus on exfiltration because that's a pretty easy one to sort of wrap your head around. And the advantage of using AWS to exfiltrate data as opposed to shoving it out over the network is that you'll avoid any of the controls that traditional defenders might have in place. Right? You're not going to see a big RAR file going outbound or a big imbalance in your net flow. It's just going to happen through the Amazon API, and you're going to have to be sort of cloud aware to figure out how to catch that. So fortunately, there's a really good feature that you're going to have to get to know really well, which is called CloudTrail, and that is the logging functionality of the Amazon API. So CloudTrail produces very verbose JSON documents about all the activities that things are taking within your environment. And in this case, we'll talk about a particular technique that has been theorized about. So, and that's again sort of talking about the snapshots. Forrest mentioned them. I mentioned them. Excuse me. They're super useful for forensics. They're super useful in ops. You can use them to back up. So it tends to be a permission that's fairly widely granted to instances, right? You want people to be able to back up their instances. You also want to be able to share those instances, maybe with a disaster recovery account, move them around. That ability is sort of a key value proposition of Amazon, so it's something that they make possible. But as an attacker, that's also a pretty juicy way to get some of your good data. So we mentioned earlier that the really high-end threats, they prefer credentials over dropping tools, right? There's no reason to go to disk on an ephemeral instance if it's going to be gone in 24 hours. So you're not going to see as many persistence locations most likely. They'd rather not even dwell in memory if they don't have to. If they can get creds and act as a legit user, that's a much quieter way to move around your environment. So a great target for them then is like a build server. So that's, I guess, the downside of the CI/CD pipeline, right, is you're going to put probably a fair amount of credential and power in your build server. And so in this instance, let's say they identify that, they popped onto your edge, that instance had permissions, and we'll talk a little bit about what an instance profile is, to take a snapshot, and they snapshot your build server, and they share that snapshot with their attacker account. So the way they would do that is they would assume the role of that instance. And instances, virtual machines in AWS have this idea of an instance profile. You can think of it somewhat like a service account, but it's basically its identity within the Amazon world. And it's a very useful function. It's a great way to lock down least privilege on these things. But it's also, as an attacker, you can hit this AWS metadata endpoint and pull those creds, and then you act as if you have the capability of that endpoint. So in this instance, we would take those creds, you do the snapshot, and then you'd move it out. So fortunately, again, CloudTrail sees all this. It's all being logged. So while you can't necessarily prevent it, you can detect it and take your remedial actions. So here is an example of a CloudTrail entry. Again, CloudTrail produces very, very verbose JSON, so I couldn't fill up my slide with that. So this actually seems to have wrapped at a different rate as well. But in this instance, we are sending our CloudTrail into an Elasticsearch cluster and allows you to sort of poke through it in Kibana, which is a pretty good way to see things. So to do that, you need to write a little bit of an ETL layer to pull it out S3 and drop it into the cluster. But you could do the same kind of thing in Athena if you were, if you knew the fields really well. So you got to get comfortable with the AWS documentation on CloudTrail. But in this instance, right, I've pulled out a couple of the relevant fields. So this is some mass data from me sort of performing that attack from one of our production accounts and moving a snapshot into my friend's account. So I did it two different ways here. The first way, so you'll see there's the timestamp. Obviously, there's this, the event name is modify snapshot attribute. That was the API call I chose to sort of search for, because it's one that it gives you the right data. So I pulled up all of those. You'll see the field that I extracted here is called request parameters, create volume permissions, add items. And then there's this key value pair. Excuse me. The user ID is a little bit misleading. It's actually an account ID. And then the value there is a masked account ID that you would see. And so you would look through this list if you're running a single account deployment, then you'd look for any ones that weren't your account number. If you're like us and you run multiple accounts, you would probably automate that comparison against a table of accounts that you have. And if it's not one of your accounts, then you need to do some follow-on investigation. The first thing you do is you probably reach out to Amazon. There's this idea of the shared responsibility model with them, right? They handle everything sort of kernel and below and all of their API stuff. So you need to reach out to them and say, hey, this account's not mine. What's going on with it? Thank you. And oftentimes they'll come back and say, oh yeah, it's one of ours. So they actually will jump into your account at certain times to clean things up and move things around. So we keep sort of a running list of known Amazon accounts. But if they say, no, that's not ours, then you file an abuse complaint and they'll go try and action that to figure out if there's this attacker has compromised the account, spun it up, whatever it is, and help you remediate. But on your end, you still want to chase down how this happened, right? And that's where you're going to use this user identity, ARN, Amazon resource number. So on the top line, you'll see this ARN here is an instance profile. So we had discussed these before. So this was a case where I sort of simulated an attack from the edge, and that's where I would have exploded onto an instance. I would have grabbed creds from the Amazon metadata service, and then I would have pretended to be that instance and done the snapshot. So your follow-on activity here would be to go do some forensics on this instance, figure out who had been on there, what had happened, how that got compromised. The other way to do it is as a user. So if I did it as a user, you would see something along these lines with a user ID. So then you could reach out to that user and ask them if they did this. If they said no, probably roll their creds and move on through that. So this is one example of many, many, many ways to abuse the AWS API. It's why I love my job, because I get to keep figuring these new ways out. And also it's a lot of fun because Amazon is constantly innovating and releasing new services that are both super useful and probably ripe for abuse. So here's another quick one. You could also share a machine image instead of just a snapshot. You could set up cross-account sharing for various data queues, for S3 buckets, for you name it. So yeah, it's an evolving landscape on which to hunt, and it's just a lot of fun to work with.